Have you ever bite into a lemon and you get like this sour taste? Have you ever stepped on a bar of soap and slip? Hi, my name's Kimson, and today we are going to be talking about acid and base. So, what are acid really, and what are base? Well, to put it simple, acid are like, how do you say this? Anything that tastes sour. When you add to a litmus paper, it turns red, and it can also dissolve many metals. Base, on the other hand, has a bitterness taste. It feels slippery, and well, when you add it to water, when you add it to an acid, it neutralizes each other. To further explain acid and base, we go back in time to 1923, where two guys, Bronsted and Lowry, defined acid and base. According to Bronsted-Lowry definition, an acid is anything that donates an H ion. For example, hydrochloric acid, when react with water, you form an H ion. And you also get hydroxide. Aqueous, obviously. And on the other hand, base, according to Bronsted definition, is a proton acceptor, mainly H ions. Ammonia, NH3, when react with H2O, which is water, you get NH4 plus ammonium and hydroxide. So, as you can see here, ammonia is the base, because what it's doing is it is accepting an H ion from water. So water, who donates a proton, is an acid. And that's the definition for a Bronsted-Lowry of base. Now, you're probably wondering why water can how can water be an acid and be a base? Well, it's simple. Water is amphoteric. Water can act as a base and an acid. That's what amphoteric means. So now you're wondering, how is acid and base going to be any useful to me? Well, what if you're trying to find the concentration of the acid? You're wondering, like, how strong is this acid, Like, is it going to hurt me, Because acid dissolves, especially strong acid like hydrochloric acid, concentrated hydrochloric acid. Take a dose of those and you can burn your skin off. We're going to explain to you acid and base work in chemistry.
You're set to do your experiment. Start by measuring the initial milliliters, which is about 0.81. Before I forgot that phenolphthalein, you add about 2 to 3 drops to help you indicate when the reaction has reached the end point.
You will notice that when you add the base, it would turn pink for a second. That is the base reacting with the phenolphthalein. So you carefully add your base to the acid slowly so you won't overshoot it. You will notice that the pink will stay longer and longer. So you want to carefully add it, stop and whisk it here and there. Another crucial part of this experiment is that you add deionized water around the flask, because you have acid and base splashing around, and adding water won't affect the molarity. So you keep on adding. You will notice that now the whole solution became pink for a longer time. You're reaching the end point, so now you want to slowly add the base. You want to be real careful in not overshooting this, because then you would get the molarity of the unknown acid wrong. So I'm gonna add drop by drop. Also remember, if it lasts for about 30 seconds, from pink to colorless for about 30 seconds, and it has reached the end point. And now we have reached its end point. A very light pinkish color. Now, since you have determined the end points of this reaction, write down the final milliliter use of the base. 13 point. What is that? 13 point. 29. So you subtract the final minus the initial to get the total milliliter used to use to determine the molarity of the unknown acid. This is a very, very dark color. You overshot it. When your calculations, this is gonna mess up the molarities of the unknown acid, which brings your grades down.
So the experiment that Dave did earlier is what you call an acid-base titration. And to find the molar concentration of the unknown acid, what you would do is to determine the moles of hydroxide used. And how do you determine the moles of hydroxide? Well, basically, all you have to do is find the molarity of hydroxide, multiply that by the liters of hydroxide used to titrate the acid. Then you would use a mole ratio. Usually it would be 1:1. So, for example, let's just say that this experiment was a 1:1 mole ratio. Now you have the numbers of moles of H ions. Then you would take the moles of H ions, divide that by the volumes of H ions that was used in the acid-base titration. And there you have it. That's the molarity of the unknown acid. Thank you for watching.